Today we are going to work on one more method. This should be our final method for solving quadratic equations. So far we have tried several different methods and we found out that each one has its strength and each one has its drawbacks. We started off with completing the square, and that was fabulous as long as the middle term was even. We also tried using square roots, which was really easy as long as there wasn't a b term. Some of them we were able to factor. If it's easily factorable, we found out just how fast that was. And sometimes we can also graph the related function, especially if we happen to have a calculator handy. But each of those methods has its drawbacks, and it really helps to have one method that's kind of a go-to method you can use anytime, and that's the quadratic formula. The deal is, if we could somehow take this general formula ax squared plus bx plus c equals 0 and get x by itself, then we would have a little magic formula that we could just plug numbers into and it would work every single time. Alright, watch out because this is about to get seriously ugly. You start with the standard form. Guys, just follow along. Please do not try to copy and write everything down. Just follow along. First thing we do is to get the variables on one side, numbers on the other, so we subtract c. Then we have to get rid of whatever's in front of the x squared, so we divide by a. Okay, here's where it starts to get ugly. We take half of b, we square it, we complete the square and write it as a square. At this point you're just following along. Simplify the right side using some common denominators. Take the square root of both sides. You remember that step from completing the square. Use the quotient property to simplify the radical, which is an algebra 2 thing. We subtract from both sides, and when you're all done, drum roll please, you end up with this giant but very handy formula. This is the quadratic formula, and it goes like this. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Or for those of you a bit more musically inclined, it goes like this. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over 2a. One more time. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over 2a. You will need to know that formula very well because we'll be using it over and over and over. Alright, here is an example of the type of problem that you might need to solve. We are not going to solve this one with completing the square because we have an odd number in the middle. We're not going to solve this by factoring because it's just not convenient. We're not going to solve it by graphing because, oh darn, our calculator ran out of batteries. So our final go-to method is the quadratic formula. Alright, first thing we need is to put it in standard form. So we will write 4x squared plus 7x, subtract the 15 from both sides, giving us 0. Alright, here's the trick. This value next to the x squared, that's a. The value next to the x, that's b. The value at the end, the constant term, that's c. Take each of those numbers and we plug them into the big formula. X is equal to negative b, well b is 7, so negative b is negative 7, plus or minus square root. Then we have b squared minus 4ac. b squared would be 49, minus 4 times a, which is 4, times c, which is negative 15. All that goes over 2a, which all goes over 2a. 2a would be 8. It's best to go ahead and just do that either mentally or knock it out right immediately instead of actually writing 2 times 4. Okay, simplify. Order of operations tells us we need to do what's under the radical first. Negative 7 plus or minus the square root of. Grab a calculator, work it out by hand, work it out mentally, whatever works for you, but go ahead and work out what's under the radical. That comes out to 289. Still over 8. Keep going. Alright, the square root of 289, lucky for us, comes out even. That would be 17. So we now have negative 7 plus or minus 17 over 8. Let's see what our two answers are. The first answer would be negative 7 plus 17. That would be 10. 10 over 8 reduces. Now we do the subtraction. We do negative 7 minus 17. We have negative 24. Negative 24 divided by 8 is negative 3. And as before, I always strongly recommend you either graph it or plug it back in or do something to verify that these answers work in the original problem. Example number 2. Now, if you wrote down the first one, I'd recommend you just watch the second. If you did not write down the first one, it would probably not be a bad idea to go ahead and write down the second one. We'll start with the same process. We need to get it into standard form. 2x squared, subtract x from both sides, minus 7 equals 0. All right, values of a, b, and c. Our value for a is 2. Our value for b is an implied negative 1. Our value for c is negative 7. Plug that into the formula. X is equal to negative b. Well, b is negative 1, so negative b would be positive 1, plus or minus square root b squared. Well, that's negative 1 times negative 1, that's 1, minus 4ac, 4 times 2 times negative 7, which all goes over to a. 2 times 2 is 4. Continue simplifying from there. Again, we're going to go ahead and work out what's underneath the radical sign. X is equal to 1 plus or minus the square root of, unfortunately, one that does not come out even, over 2a. When it does not come out even, you're going to want to go ahead and round it probably to about the hundredths place. So we'll take the square root of 57. Square root of 57 is approximately 7.55. So we have x is equal to 1 plus or minus 7.55 over 4. Final answer. Let's go ahead and work both of these out. We have 1 plus 7.55, which is 8.55, divided by 4, approximately 2.14. We also have 1 minus 7.55, and divide that by 4, or approximately negative 1.64. As always, check your work either by plugging them back in. Since we did round, you know it won't come out exact, but it should be awfully close. Or you could also graph to see if the roots appear to be around a positive 2 and somewhere between negative 1 and negative 2. Take just a minute, see if you can plug this one in and find out what happens. Let's pause the video, wait till everybody's ready. In this case, what we find out as we finish up with the radical sign, the square root sign, is that we're taking the square root of 0. Taking the square root of 0 is just plain 0. When we add or subtract 0, it's the same answer. So we end up with two answers that's really the same number, and we just have a single answer, 4. As you can probably guess, when you look at the graph for this one, you'll notice that it has only one x-intercept, which occurs at positive 4. If the class would like to do one more, you can pause the video at this point, try one more, and I will put it up shortly. Otherwise, you can just continue watching and we'll go right through. And here's the answer for this one. I do need to point out that you will get a just barely different answer if you go ahead and punch it in one step instead of rounding at the point of the 3.61. It's probably a little bit more accurate and a little bit better practice to go ahead and use your calculator to do 5 plus, hit square root 13, hit enter, then divide by 6, rather than rounding at this middle step. But if you do, I'm not going to worry too much. If you're close, if you're off only by a few hundredths, I'd be okay with that. Okay. Now, when do you use each of the methods? Now that we've got this whole toolbox of methods, how do you know when to use each one? Well, anytime you have a quadratic equation which can be easily factored, either a GCF or a pair of binomials or a difference of squares or something that's fairly obvious and fairly quick, factoring is usually the simplest, fastest, most efficient method that you can have. However, not everything can be easily factored. Some things can't really be factored with whole numbers at all, so it's not a good time to use factoring. Graphing is a fabulous way to get a quick answer, or if you just want to know the approximate solution, you can pop out a graph on your graphing calculator in almost no time and determine about where the answers are. Even doing it by hand, you could get a good approximation. Finding square roots is ideal when you don't have a middle term at all. X squared equals d, because all you have to do is take a square root and put a plus minus on the front and you are good to go. Completing the square you can use anytime. However, we found out that it's really best when you have nothing in front of the x squared, that would be when a is 1, and when the middle term, that's b, when that one's even, because it makes it so much easier to take half and square things. And then finally, when you don't have another method just staring you in the face, the quadratic formula is a good go-to method. You can use it anytime. All right, take a look at each of these, and we'll see if we can figure out which one is the best method to solve. Letter A, we're starting with 10x squared minus 7 equals 0. First thing you should notice is that there is no middle term. There is no bx. This one would be a piece of cake to solve just by adding, dividing, and taking a square root. So we would solve it using square roots. Looking at the second one, you should notice it's pretty short and there is a GCF. Since there is a GCF on this one, you can factor out a GCF and have an answer in no time by using factoring. However, another perfectly good response here would be to use completing the square, because you have nothing in front of the x squared and you have an even for the value of b. Finally, on the last one, you can see that maybe this could be factored. It's entirely possible it could be factored. However, this one's certainly not convenient. It's also not a good candidate for completing the square because of the fractions involved, so chances are you would probably use the quadratic formula. Now, since this is a video, I'm afraid you can't come up to the smartboard and drag things around, but take a minute, discuss with your partner or with a small group which of these methods would be used with which equation. Please pause the video, decide which one you want. Now that you've had a chance to discuss, let's go ahead and take a look at what each one would be best suited for. Let's start off with the one that doesn't have a b term at all. The one with no b term, this third one, that's ideal for square roots. You just add 10, take a square root, stick a plus minus in front of it, and you're done. Now, as far as completing the square, we're looking for something that does not have a first coefficient in front of the x squared, definitely not this one. And we're looking also for something that has an even value for b, so probably not the first one. Completing the square is ideal for this third one. Factoring, we're looking for something convenient to factor. Well, if we were going to factor this mess, it would be 5 times 3 and then figure out what goes in the box. Okay, no, we're not doing that. So factoring, however, on this one is a piece of cake. We're looking for pair of numbers multiplies to 12, adds to 7, got it, 4 and 3, we're done. We can figure that one out right away. Which leaves the last one. It does not have any other convenient method, so we would use the quadratic formula to solve that one. Okay, application time. Let's see how this actually plays out. For the period 1971 through 2001, the number y of films produced in the world can be modeled by the function y is equal to 10x squared minus 94x plus 3900, where x represents the number of years since 1991. We are trying to determine in what year 4,200 films were produced. Now, you can imagine there are lots of ways to do this one, but let's go ahead and start by using the quadratic formula because that's what our instructions tell us we should probably do. We want to know when we have a result of 4,200, so we will fill in place of y 4,200, and then the rest of the function just follows after that. Okay, since we are not yet in standard form, we would need to subtract 4,200 Purpose of that would be to get it equal to 0. Once you've done that, here's your value for A, here's your value for B, there's your value for C. See if you can figure out by plugging it into your calculator, writing down the formula, plug it into your calculator, what would we get as our value of x? Formula one more time. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over to a. Pause the video, find out what that would be. Alright, welcome back. Plugging all those giant numbers makes you really grateful you have a calculator, huh? Okay, once you plugged in the huge numbers, you should find out you've got 94 plus or minus the square root of almost 21,000, or 94 plus or minus 144.35 divided by 20, giving us about 11.9, which is year 12, and about negative 2.5, which would be year negative 3. Now, keep in mind, year negative 3 would imply that that's 3 years before we started counting, and since that is outside of our domain, we don't count it. It has to be within our domain. Well, where does that put year 12? Year 12 would be 12 years after 1971, or the year 1983. Since 1983 is within our original domain, that's our solution. If for some reason we found out that one or both of the solutions were not in the original domain, for example, both of them were negative before we started, or perhaps both of them were past 2001, past 30 years, then we would simply say that there is no solution. It is possible that they could both fall within the domain. It's possible that one of them may, as it just did, and it's possible that neither might. So you have to take a look when you're finished with each problem to see what makes sense in the context of the problem. Okay, your homework is to take the problems that we wrote yesterday on the Did You Hear, and since they're all now nicely written in standard form, take each of those numbers, each of those sets of numbers, plug them into the quadratic formula, and solve them using the quadratic formula.